Hello, welcome to the online educational resource for electronic engineering students for the subject digital electronics. Today we are going to study the topics application of flip-flops. In the previous screencast we have seen the various types of flip-flops like SR, D, JK, T flip-flop. These are used for various applications like debouncing switch, latch, register, counter. We will see these applications one by one. So first we will see the debouncing switch. Whenever a mechanical switch is pressed, it debounces back, thus providing a continuous pulse train of 1s and 0, and hence it makes a circuit malfunction. To avoid this debouncing back and forth, a delatch is used with arrangement where the inputs are given high and high to the S and R, and a switch is connected which is given to the ground. So this can be either connected with A or with B. Whenever the switch rebounds, a condition exists where neither of the A nor of the B is connected to any of the input. Thus the A and B both gets 5 because they are connected to 5V via resistor, and hence the conditions like A and B both are high exist, where the truth table says that the next state is same as the previous state or the current state, means no change. So whenever there is any debouncing, the output does not change. Thus it immunizes the circuit from the debouncing of the mechanical switch. This is a very basic application of flip-flop, but it is very useful for all the practical applications where the mechanical switches are used. For the normal case, whenever the switch is connected to either A or B, then we have got set or reset condition, and this 0-0 condition, which is a forbidden condition, can never exist because switch has to either to A or B or nowhere. It cannot be connected to A and B at the same time. Hence the forbidden state is also bypassed. The next application is the delatch. It is the extension of the SR flip-flop where the S and R inputs are short circuited with the help of a NOT gate, so that whenever one input is 1 high, other automatically becomes low, and when one input is low, other becomes high. Hence only the two states like 0 and 1 exist. So whenever this is 0, output becomes 0, and whenever D is 1, output is 1. So this makes the D flip-flop suitable as a latch where it can store 1 bit of information. Whatever is there in the D, that is stored in the flip-flop. So it is known as a D flip-flop or D latch. The next application is the shift register application. There are different types of shift registers like serial input, serial output shift register, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So we have SISO, SIPO, PISO and PIPO shift registers. We will see the logic diagram of each of the shift registers one by one. This is the logic diagram for 4-bit shift register where 4 flip-flops are connected in series. The output of one flip-flop goes to the input of the next flip-flop, and so on and so forth. And the final output is taken from the last flip-flop, and the input is given to the first flip-flop's input, and a common clock is given. So this is the timing diagram or a truth table of this. So the data given here is 0 1 0 1 0 pattern. So initially we get 0, so next time it is shifted to QA. This D goes to the QA. in the first clock. In the second clock, this goes to the B, then it goes to C, then it goes to QD, and from the QD the output is taken. In this way, all the data are shifted serially. We give data from input we get the data input, we give the data serially, and we get the data serially. Hence, this is known as SISO flip-flop. Next, we see the serial in parallel out shift register, or SIPO shift register. It is very similar to the previous one, like this. The only thing is that the output is here taken from each of the queues at the same time. So data is inserted serially but taken out 4 bits at a time. So it is a parallel output type of operation. Here we can see the truth table. The QA is here. The Q is inputted. So here we get a data QA, then here shifted and comes out. But the data is taken out from QA, QB, QC and QD all together. Hence, we can say that the data which is serially inputted is taken out parallelly. So the speed of inputting is low and outputting is 4 times higher. So here what we can do, we can first insert data after by the clocks. After 4 clocks, the data is shifted in the flip-flops, and then we can read the 4 bit at the same time. This is the example of the 4 bit shift register. The next is the parallel in serial out shift register. Here data is inserted parallelly. So here is a mux connected, a 2 to 1 mux connected to input of every flip-flop. So initially the arrangement of the mux is made such that the lower inputs are enabled, so they are available at the D of every flip-flop, and after 1 clock pulse all the data are shifted inside, so they are stored there, and then the mux is switched to the upside so that no more data can be coming from the input side, only the data of the upper part, that is D, T, Q are to be shifted outside. So here data is inserted parallelly, and then after switching data is taken out serially from the last flip-flop. Hence this is known as a parallel input serial output shift register. Here also the speed of the input and output are mismatching. First data is inserted and then 4 clock pulses are required to get the serial data out. So here data inserted was 0 1 0 1, and here you can get output as 0 1 0 1. Similar, this is the output 0 1 0 1. The next one is the parallel in serial out shift register. This is the most simple register where 4 registers are just kept in parallel fashion. There is no interconnection between them. Only the common is the clock. So when the clock is given, the input of each flip-flop goes to the output separately, here to here, D to Q independently. Means 4 data inputted at the same time, and we get the 4 bit data at the output same time. So we can see here PC, PD, PV, PA as input. In the second clock we get 1 0 1 0 as the output. So whatever you give 0 0 1 1, you get 0 0 1 1 0 1 1 0. Here you get next time 0 1 1 0, next time that you get. So this is the example of the parallel in parallel out shift register. So today we have seen various applications of flip-flop, that is debouncing switch, latch and shift register. Next time we will see the application as counter. For today's lecture, we have questions. Question 1. List various applications of flip-flops. Explain any one. Second, list various types of registers. Draw logic diagram of any one. Explain with timing diagram and truth table. Thank you.